A centre pivot's main characteristic is a fixed centre tower that has a water supply and power source available around which the spans and towers rotate. A centre pivot's main structure and components are self-supporting frame spans, each end of a span supported by a tower. The tower contains gearboxes, drive wheels and the drive motor, either hydraulic or electric. Flexible mechanical or hydraulic couplings connecting individual spans, system alignment maintained by micro switches, alignment valves and control equipment. Outlets or sockets along each main pipe allowing emitters to be attached. Emitters attached directly or more commonly on rigid or flexible droppers. We now introduce Pat Daly, an irrigation consultant from the Darling Downs, who will give a detailed explanation on the componentry of the centre pivot.
Basically, with a centre pivot system, as the name suggests, you've got a centre pivot tower, and these towers can be made up of towable towers or skid, both in a skid tow arrangement or a wheel tow arrangement, and they come in a four-wheel tow or two-wheel. And with the pivots, generally they are fixed pivot towers, and they can be run on commercial power or generated power on site. The tower itself is made up of four legs generally, and it'll have a riser pipe that goes up the centre of the tower, which attaches to a pivot elbow. Through the centre of that riser pipe is what we call a J-pipe, which is really the conduit for the electrical cable to feed up through the inside of that pipe. At the top of the elbow, we've got some of the start of the electrical components are there, which is a collector ring. The collector ring being the part where all the wires will join into a circular box that only works on brushes and contacts. This allows the pivot to do a full circle without twisting all the wires. Also, you've got attached to that pivot tower is the control panel. Control panels come in variable technology, like from the very basic machine where you can control the percentage that the outside tower is walking at, that's a percentage of the speed, down up to the very high-tech ones where you can vary the speeds and change the rate that it walks at various parts of the paddock.
The other component that you should have on a machine, particularly if it's using surface water, is a filter. The filter is best placed at the centre point. There's not very much point putting the filter back at the pump. The reason being, if there's anything in the pipe or there's any work that needs to go on with the pipe, you run the risk of putting dirt through the sprinklers.
All pivots, new pivots, are all getting filters put on them. We started off with very simple filters at the pivots or the pumps, and now we're going to a rotating filter that a man can just go up, and each of the filters have got a pressure gauge on the intake side and discharge side, and as soon as there's a differential you just have to wind the handle around a couple of times and drain it away. The cost of your filters for us has been paid for in 12 months just on your labour. You save from having block jets or non-uniformity of distribution. All of the pivots, we put the sand trap on the last tower, we lower that down to, with a piece of polypipe, down to just at the wheels, and we can crack a 2-inch plastic valve there and just drain that every time. And we also drop another drain at the very end of the overhang, so that we can drain the overhang out as well. And if you keep it clean out like that, you don't have a problem.
A lateral move is used to irrigate rectangular fields. The main structure and components are a pump cart supplying water and power, self-supporting frame spans, each end of a span supported by a tower. The tower contains gearboxes, drive wheels and the drive motor, either hydraulic or electric. Flexible mechanical or hydraulic couplings connecting individual spans. System alignment maintained by micro switches, alignment valves and control equipment. Outlets or sockets along each main pipe allowing emitters to be attached. Emitters attached directly or more commonly on rigid or flexible droppers. We now introduce Pat Daly, a consultant from the Darling Downs, who will give a detailed explanation on the componentry of a lateral move.
The lateral moves come in a couple of different configurations. You can get a 2-wheel cart or 4-wheel cart. It can drag a hose, a soft hose or a hard hose. The hard hose has the benefit of being able to pull more hose because it's got less resistance on the ground. There's also the ability for a ditch feed, so that's where you've got a ditch that the machine draws water from. In these cases, the cart will be mounted with not only an engine to generate the power, but it'll also run a pump off one end of the engine that will pump water from the ditch. The guidance systems in these cases can vary. You've got a furrow guidance, which basically is a long arm both in the forward and the reverse direction of the cart, which activates a micro switch to keep the cart square to the paddock that you're irrigating on. Or you can have a wire guidance. This is where you've got a wire that's just about 450 mil above the ground level, and the arms still do the same thing. It's got a micro switch in the forward direction and the reverse direction to keep the cart square. Also, to keep the cart square, up on the this is particularly the case where you might have a pivoting lateral. Pivoting laterals are sometimes referred to as a racetrack configuration. Well, in the case of one of these machines, on the centre elbow, you would have a proximity switch, and that also helps keep the cart square with the rest of the machine when it's in a lateral motion. The other guidance systems is a buried wire, and this is where a sensor picks up a wire that's buried beneath the ground, and it's really working the same way, except the wire is all buried, and it's very sensitive to any change in direction. It's sometimes used where there's slight bends to overcome. However, I wouldn't recommend it for that reason, because it can change the uniformity in the way that the water is applied. The other way that's just recently been used more often is a GPS. That's where it's got a GPS reference of both the cart and the end tower, and I'm not sure whether that's been used in a racetrack configuration, but if it hasn't been, I'm sure it's not far away. By far the most intrusive to any farming operation is the wire guidance, because it's in the way of any farming activities that you might want to do across that laneway. The other thing with a pivoting lateral that a standard lateral may not have is, with a pivoting lateral, the cart is normally a four motors to drive the cart. So that's one motor for each wheel. In a standard configuration lateral, you'll just have two motors which drives drive rods similar to the base beams out on the spans. So two motors driving 4 wheels.
So we've gone for the underground wire, the guidance system, so it's the same wire between both machines. The reason we went with it, because we wanted it just to put it in the ground and then forget about it. We'd seen other people, it gets, over time they collapse, or, you know, on the side of the channel, if it floods over, it's a bit of a concern. We're also taken by the accuracy of the underground wire. I think we're very impressed with the accuracy we're getting. It's 700 under the ground. And yeah, it was a bit of a challenge to get it in, though we had a trench of it was all put in with the GPS, and then we just put the tractor over the trench on a GPS line and had a rig and just laid it down. So it was quite challenging because it was the very wet season when we put it in. So, but once it's in under the ground, we've been really happy with it. It's been great.
With the ditch feeds, as far as the pump goes, the pumps have the capacity to look after the complete machine in most cases. And when I say a complete machine, with a ditch feed, quite often you'll have 2 directions from the cart. So the cart will essentially be in the centre of the machine. And in this case, there wouldn't normally be a race course configuration or a pivoting configuration. So therefore, there's generally a lot of water needed, and the pumps are quite large on these carts. And so they have a large suction pipe on a floating suction screen that goes into the ditch. And the reason why it floats is that along a ditch you may have changes in water level that the suction pipe needs to move up and down to. The suction screens are generally set up so that you've got backflush water that can blow back across the screen to clean them, because there is a lot of trash and shells and frogs and fish and things get in these drains that need to be cleaned off the screen. When the machine's got to be moved anywhere, there's a winch on those carts that can winch the suction pipe up. They are generally considered self-priming type pumps, however they're not designed for that. The 2 ways that most times are used to prime the pumps on the carts is a vacuum pump, which once the suction pipe is dropped in the water, the vacuum pump will lift the water to the pump. Or alternatively to that, you can use a exhaust venturi, which causes a vacuum and lifts the water into the pump. The controls are generally all on the cart, and despite these being engine drive, they can be automated quite successfully. And generally they would have a solar panel to keep the control panel alive for any remote signals that it might get. From the elbow there, the cable is run out onto the spans, and each of those spans are joined with a flexible joint, and there's mainly 2 different types of joins that do this. It's a rubber boot, or you can get a split case coupling. Both of them are just there to seal the water. It's not anything structural to hold those spans. And different brands have got a different way of joining those spans. We have like a ball and socket type arrangement, which goes from the fixed pipe to the receiver. We've got some horizontal and vertical connections that allows a free movement between the spans, but holds the receiver up to the stationary span. Each of the spans are designed to take weight with a downwards pressure, and that's why if you see any of them, they've got a slight bow in the pipe, and they're all the structure underneath, which is the truss rods and V-jacks. The V-jacks are really the part that supports everything back to those truss rods and keeps the truss rods taut. Between those V-jacks we have a spreader bar that holds the V-jacks out into an angular configuration, which gives it more strength, not only with the downward pressure but also if there's any undulation that the spans might have to ride over. At the end of each span there's a couple of different ways of attaching the legs to the base beams. There's a double leg arrangement, and there's also a couple of brands that use a single leg that comes off a gusset that's welded onto the end of the last pipe of the span. Just on the spans, those spans are made up of short lengths of pipe which are bolted together with flange joints. With each flange joint having a V-jack and spreader bar to support it. But when it attaches the legs, the common thing with all of them is those legs are attached to what we call a base beam, and the base beam is really what carries all the drive train mechanism. So that's your centre box in the case of an electric machine, and then your wheel gearboxes and wheels, drive shafts and couplings. With a hydraulic machine, of course, you don't have a centre box. You've just got wheel boxes that have got hydraulic motors on them. The other thing a little different with a hydraulic machine is that you will have hydraulic pipes that run from the centre point out to each of those wheels, and at each joint you will have a proportional valve, or a spool valve as it's commonly known as, that will control the flow of oil to each of those motors to stop or control how much oil is going to the motors. Obviously, the further out you get with a centre pivot, the faster the outside wheels have got to go, because it's got to travel further. With an electric machine, they work on a micro switch up on the tower, and really how this works is when the outside span gets out of alignment, it activates a switch, which then activates that set of wheels. And the wheels will travel forward until the micro switch is switched off. There's a few different ways of doing that, but basically they're all using the same micro switch. They also have an override switch. If it gets out of alignment too far, that will shut the machine down. And this could happen if you had a machine bogged at some stage and it can't keep up with the next tower, well, it'll stop the machine. The cable runs all the way from the collector ring right to the last set of wheels, and quite often if it does have an end gun on it, well, that cable will also supply power to a booster pump. The reason for the booster pump is that centre pivots are low pressure machines, and the end gun is a high pressure piece of equipment, so it needs to have the pressure boosted, and this pump is supplied out on the end tower to supply that end gun. The end guns have a part circle function on them, and normally that's adjusted around the 210 degrees. So that's done at commissioning generally. The other parts, moving back over the machine, it's made up of each of the sprays will have what we call a gooseneck, and that gooseneck comes in a couple of configurations: galvanised steel, PVC, and also with the polyline machines uses the hose straight out of the top of the span pipe. Each one of these goosenecks have got a hose, either a rigid poly riser, or sometimes with old machines it's galvanised steel pipe, or PVC, and also flexible hose. Recent times, flexible hose has been the main one that's used, and each system has a unique sprinkler pack design which gives you a certain ground clearance with a particular model spray to suit the application. The different sprays that are available are basically a rotator, a spinner, a static plate and a leaper system, and each of these have got their own application. They also are used generally, most always now, is a pressure regulator, and those pressure regulators are found from 6 psi to 20 psi. You can get things like truss rod clips to raise the ground clearance of the sprays. For example, if you might have a corn crop at one part of the season and another season you've got a loosened crop, and you might want to change the sprinkler heights. This should be done in conjunction with the sprinkler chart when it's been produced in the factory.
The truss rod clips, yeah, we use them. We have what we call our standard machine, and we put them on all our machines. Basically, it spreads the area in which you're wetting. Again, it helps with your management because it helps with your infiltration rate. So you're able to, again, it may be a reason that you don't need to go to 15 psi regulators. You can go to 10 psi and use truss rod clips. It just spreads your water. So again, you can probably put more water on in a pass because it's increasing your application, your infiltration rate. Yeah, look, we just think they're very cheap. It just adds probably 25% to the amount of water you can put on in a pass. Certainly with spinners, we've found that. Yeah, no, look, to us, they're just a standard thing. Again, we'd put them on. There's no real disadvantages. The only one could be, again, is how much evaporation you're going to get by having wetted area, a larger wet area. Now, if you could put more water on, then you're going to get less evaporation is one of the theories, if you can put more water on in each application. But yeah, we just use them as standard because of the ease of management and how it, and that's a critical factor. Management is a big thing with these machines, and making management easier and making their labour commitments less and less is one of the key drivers for the success of these machines.
At the end of each span where the wheels are, quite often you will see what they call boom backs, and they can be one direction boom backs or they can be bi-directional. And also there's another system, the boom backs are designed to put a half circle spray pattern behind the wheels with the idea of not watering in front of the wheels. However, there are another boom back arrangement where the sprays that are used run both front and back of the machine, and you're putting out a full circle spray. This has the effect of giving a bigger wetted footprint and eliminating water pooling.
Every one of our pivots has got boom backs, so we don't put a pivot in without boom backs. Our part circle pivots all have double boom backs so that we can control them with valves. For the onion growers on the smaller pivots that we're putting in for them now, we're putting dual boom backs so that they can farm sectors of the pivot and come back over it with watering both ways.
You may want barrier stops out in the field. Now this can be to stop a machine, or it could be simply to reverse a machine if you've got a system where it goes so far and you want it to walk backwards. Barrier stops can be made up of a fixed barrier stop or a portable barrier stop, and simply they activate a switch out on whichever tower is going to suit best. It doesn't always need to be the last tower. The other area that also can happen is back at the collector ring. However, most times this area is only used for the provision to stop and start an end gun. Even if you were to stop and start the machine from out at the centre point, it would always be advisable to still have an infield stop. Also, the control panels have got a lot of features in there that may not always be used, but one of the features that all of them have is to stop and start a pump from the pivot, or you can have the pivot shut down or the pump shut down via a valve, which simply closes off when the pivot's got to the desired area in the field and rises the pressure in the main line to shut the pump off. The machines themselves come in different span lengths and also different pipe sizes and different pipe materials. In the materials, we've got galvanised steel, we have polyline machines, we've got aluminium machines, there's stainless steel machines and chromium nickel machines. With the galvanised machines, they're normally the ones that would be polylined. In that case, there's not very many stainless machines and aluminium machines, but they do have their place in the market. The other thing that varies is pipe sizes. So we have pipe sizes from 4-inch, 6-inch, 6 5/8, 8-inch, 8 5/8, and 10-inch. The reason why these are referred to in imperial measurements is that's the way they're built in the US, where most of the pipes are built.
There are a range of span lengths available from manufacturers. They range from 34.2 metres to 62.4 metres, commonly 51.2 metres. The width of your farm machinery and row configuration used must be considered when choosing span lengths. Choice of pipe diameter can significantly affect operating costs. Smaller pipes result in greater friction loss and more energy consumption. On longer machines, inner spans have a larger diameter pipe compared with outer spans. This telescoping of different pipe diameters is used to balance capital and operating costs.
The size of the pipe will determine the friction loss in the machine, and the greater the friction loss, the more energy. So your running costs, you need to lower your friction losses as much as you can. And obviously, especially on pivots where you're trying to, some people are trying to go bigger than 100 hectare circles, then they're trying to do 12 mils a day and that sort of stuff. You've really got to move a lot of water because the big acres are the furthest away from where the water is entering the machine. So normally you would sort of telescope the size of the pipe down. As you move out along the machine, the pipe can get smaller. The biggest pipes you can do are like 10-inch. And then you can go down to 8 5/8, 8-inch, 6 5/8, and so on. And your overheads, your overhang pipes are even smaller. And you do that, and the person selling your machine should be able to do that on your sprinkler chart. It should bring up your resistance. Any of the design programs that you're using for your machine, they will be able to calculate for you a friction loss in the machine and the head required to operate the machine. So it's a critical part. It's one of the areas where people, you need to compare apples with apples, because quite often people will cheat on the running cost to give you one less span of a bigger pipe because it's cheaper just trying to win the market on price. So that's just one of the issues you really want to look at.
Pipeline valves are installed to control the amount of flow or to protect the pipeline. A flow control valve should be installed in the pipeline near the pump for each water source. For the most efficient operation, the control valve should be fully open once the pipeline is up to pressure. Pumping against a partially closed valve causes a pressure drop, which wastes energy and increases operating costs. Check valves are placed between the pump and the pipeline to prevent the backflow after shutdown. This minimises the risk of damage to the pump. Flushing valves on the end of the centre pivot remove sediment and trash that can block sprinklers. Wheel rutting is reduced by fitting larger wheels and tyres. Using lowest recommended tyre pressures will also assist. However, larger wheels and tyres increases the load on the gearboxes and drivetrains, which can result in premature failure. Existing ruts should be filled in before fitting larger wheels and tyres, as the larger tyre will tend to deform and widen the rut, placing greater stress on the drivetrain. A wheel and tyre size larger than the standard 14.9 inch by 24 inch can be specified when ordering a new machine. Other wheel sizes available include 16.9 inch by 24 inch, 16.9 inch by 28 inch, and 11.2 inch by 38 inch. Two wheel configurations are most commonly used in Australia. However, other configurations are available from manufacturers.
We chose the option of the larger size tyre, this being a 16.9 24, and just for the little bit of extra cost involved, we thought that was just another advantage to reduce any wheel rutting and do a better job, as well as giving a bit more traction, I guess, too. So just for the bit extra cost, we thought it was a worthwhile thing to do.
There's basically two standardly different boxes. It's whether you have a towable gearbox or an untowed gearbox. And that's something you've really got to think about early on when you're in the design of the machine. Is this a machine you're likely to move from site to site? If it is, then you need to make the call early on that you want the towable gearbox. Right? The towable gearboxes are basically the same as the non-tow, except they've got a lever here which you can basically disengages the gearbox and lets it freewheel. If you don't get that right at the start, you can't make these non-towable ones towable, so you'd actually have to go back and replace all the gearboxes. So it is an issue, it's something you need to think about at the start.
There are two application methods, sprinkler and leaper. The sprinkler types include static and moving plate. The moving plate sprinklers include spinner, rotator and wobbler types. Leaper systems comprise bubbler, drag hose and drag sock configurations. Some emitters can be used in both sprinkler and leaper modes. The static plate sprinkler is cheaper than the other types, but has generally poorer performance. There are only two companies manufacturing these sprinklers, Nelson and Seninger. Each machine has its own unique sprinkler pack. This pack describes the spacing, location, height, regulator, discharge rate, sprinkler model, plate and nozzle size. The sprinklers, nozzles and pressure regulators along the length of the machine are referred to as the sprinkler pack. They represent about 7 to 11% of the capital cost of a machine, but are responsible for 70% of the irrigation performance of a machine. The aim of the sprinkler pack is to apply water uniformly to the field and maximise infiltration. Modern sprinkler packs are designed to operate at low operating pressure to minimise operating cost. Sprinkler packs using 6, 10 and 15 psi pressures are available. There are two main types of emitters, static plate and moving plate. Static plates can be single, double or triple with no moving parts, wear slowly and operate at low pressures. There are three types of moving plate emitters. Spinners, these have a fast rotation and operate at low pressures. Rotators, these rotate slower than spinners and require higher pressures to operate. Wobblers, medium to low pressure emitters which produce an even distribution pattern. With a static plate, the water comes down vertically through the centre of the assembly, through the nozzle and strikes a fixed plate in the centre. The water stream is forced into the grooves on the plate and distributed as individual horizontal streams. There is no rotation of the individual streams. Flexible droppers allow some movement of the sprinkler head. There are a range of plate types with differing number of grooves and groove trajectory. Under still conditions, the throw diameter ranges from 4.9 to 12.2 metres, depending on the sprinkler height and operating pressure. These are the cheapest emitters available and have no moving parts. Uniformity can be compromised, particularly under windy conditions and low pressure. It can be converted to a leaper system using either a hose-dragged adapter or using the bubbler clip. Available in single, double and triple plate configurations. The aim of the multiple plates is to improve water distribution from the sprinkler and reduce water impact on the soil. An issue is trash collecting where multiple plates are used.
The old one we see a bit of, and I've only sold one set in 8 years because eventually we've been able to talk the grower around, is the old D3000, the static plate. They've got a number of issues, and that's why the industry's moved on, just with uniformity and the ability to get a good even coverage, as growers would understand. Many of the original pivots that came and laterals that came out in the first influx, sort of in the 80s and before, had this type of sprinkler on them. They're now very old technology, and as I've said before, I've only been forced to sell one machine that had these on it. They have more losses because of wind and evaporation, because the droplet size and the uniformity is not good, and they have quite high kinetic energy impact where it's actually hitting the ground. So they're still used, but technology has moved on.
The D3000 can be converted to leaper application using either the bubbler clip or by attaching a leaper sock using a hose drag adapter.
A lot of people saw socks as a cheap way to turn a D3000 in the old days into a leaper and actually put the water on the ground. We've actually had some issues with socks in that it makes the water very narrow where the application is on the ground. And we've actually seen it cutting furrows there and getting a constantly wet area. After several laps, you get this confined wet area and they get erosion, and actually the water running quicker when you use the socks. Some people have then gone to diking to try and slow that down, but then again that's sort of taken away their stubble or incorporated the stubble, which we've tried to encourage a lot of our growers to go no-till under these machines.
With a spinner, the water comes down vertically through the centre of the assembly, through the nozzle, and strikes a quickly spinning plate in the centre. The water stream is forced into the grooves on the plate and distributed evenly across the wetted footprint. It operates at higher pressure than static plates, usually between 10 and 20 psi. The spinning action produces a gentle, rain-like water pattern. It is specifically designed for more sensitive crops and soils, low instantaneous application rates and reduced droplet kinetic energy, minimising soil surface degradation. It provides high uniformity with better overlap and lower application rates compared to the static plate emitters. Better choice than the static plate under windy conditions. These are a popular choice of emitter. There is a choice of plate types available, producing a spectrum of droplet sizes. There are fewer grooves compared to the static plate. The throw diameter ranges from 12.8 to 16.5 metres.
The most popular one we sell is the S3000 spinner. We find it's a good all-rounder, it's easy on the management, and it's got a very low impact on the soil and spreads over a wide area, especially if you use it on truss rod clips. We're selling our machines onto a lot of the black clays or the vertisols, and not an over amount of slope. So yeah, that's by far our most. We'd probably do 80% of our machines that way.
With a rotator, the water comes down vertically through the centre of the assembly, through the nozzle, and strikes a rotating plate in the centre. A viscous silicon fluid in the rotor motor controls the rotation speed, resulting in a slower speed and more obvious streams of water compared to the spinner. The water stream is forced into the grooves on the plate and distributed evenly across the wetted footprint. The rotator operates at higher pressure than the spinner, usually between 20 and 50 psi. This results in larger droplets compared to the spinner and obvious streamlets, which give this sprinkler better wind fighting capabilities. It is designed for a wide range of sprinkling and low irrigation intensity conditions and poorly drained soils. There is a choice of plate types available, producing a different number of streams and spectrum of droplet sizes. It has a larger throw than the spinner, with a throw diameter ranging from 17.7 to 20.1 metres when installed at 1.8 metres height. It provides high uniformity with better overlap and lower application rates, and is one of the best under windy conditions.
Probably our next most popular one that we sell is the rotator. Again, it has the longest throw of virtually any sprinkler out of the Nelson range. We use it when infiltration rates are a real problem. So when we go on some sloping country or some very hard red country is when we use it. One of the issues we have with it is just how hard the water hits the ground. So again, it's that kinetic impact on the soil.
With a wobbler, the water comes down vertically through the centre of the assembly, through the nozzle, and strikes an off-centre wobbling plate. The water stream is forced into the grooves on the plate and distributed evenly across the wetted footprint. The off-centre rotary action produces a consistent drop size across the wetted footprint. It is specifically designed to apply water evenly with low instantaneous application rates, resulting in less soil surface degradation. There is a choice of plate types available, producing different droplet sizes and throw diameters. Senergy produced the iWob, which operates at similar pressure to the spinner, usually between 10 and 20 psi, and with a throw diameter range of 10.4 to 13.4 metres at 1.8 metre height. Nelson make the N3000 Nutator, which operates between 10 and 15 psi, and has a throw diameter of 14.6 to 15.2 metres at 1.8 metres height.
The next one would be the Synergy iWob. Again, it's got a long throw. Again, it's got a big droplet, and I suppose all of those three are really making your management decisions easier and allowing more management mistakes as far as overwatering. And that's why we tend to use them. Plus, they're very efficient.
The quad emitter is a Senergy product which can be used for low energy precision application, referred to as LEPA. The quad spray has 4 irrigation modes. These are bubble or LEPA 1 mode. This applies water as a fan into the furrow between rows of plants, keeping the crop canopy dry. Aerated bubble or LEPA 2 mode. This drops water directly into the furrow. Spray mode applies water in a similar way to a static plate sprinkler. This wets the entire soil surface and is used for crop germination and irrigating broadacre crops. Chemigation. Water is sprayed upwards and is used to apply fertiliser and registered chemicals to crops. It can be used to wash away certain insects from beneath the crop canopy. The quad operates at low pressures of 6 to 10 psi. There is a runoff risk as water is applied to only a small footprint. This risk is minimised on cracking soils and through good management practices. These practices include furrow diking, stubble cover retention, planting in a circle under centre pivots. These emitters are often used where there is limited water available in order to minimise evaporation losses.
Quad sprays done by Synergy, they're probably what we've seen as the best bubbler sprinkler. That's where you're putting the water on the ground, as most growers would understand it. They're very good, especially if you're on cracking country. Very difficult to use if you're on sloping country or country that doesn't crack. But you can really use those when you have a machine which is probably under-spec'd for what is, you know, the perfect design, but you want to be very efficient because you can actually use those to run the water down the cracks if your management's up to it. But they really do require a lot of management, and I'd say probably 50% more management than the spinner and the IWOB and the rotator. This is the quad spray in the bubble mode. You can see it puts the water down over probably a 60 centimetre area, and it's very efficient at putting the water on the ground. We find it very effective if you've got cracking country. So a lot of growers will go through and use a sprinkler, and then later in the season, as the ground starts to crack and the plants are using more water than they're able to apply, then they've got a real fit. This is a chemigation mode, and it's really was in the US. They used it in corn for getting mites, and also in cotton, getting up under the leaves. We use it. Some of our growers use it sometime if they're applying foliar fertilisers late in the season, but really it's very rarely used. But it is an option, and it's really a specific use sort of sprinkler. But with a lot of the chemistry we've got now, it's probably getting past. It's not used anywhere near as much as it used to be. But it is an option, but it's not a reason, I don't think, to buy a particular sprinkler, this particular sprinkler. You can get different levels of angle. This is the maximum angle. This is for corn. You can get one which they designed for cotton, which is a white plate and doesn't throw up on as much angle, but still throws up. As you can imagine, at the start of the season, if you watered like this, you can get yourself into a lot of trouble very quickly because the water runs very quickly. And running water is not what you want under these machines. You want to pond the water. You don't want to let it run. It's a very fine line, and it changes around the paddock. You've really got to know your soil type and your paddock very well, because compaction, levels of stubble cover, size of crop, all have an effect on that. But very efficient way of getting water on the ground, but higher level of management.
There are other emitters available that allow better management of water application near the wheel towers. These emitters are part circle in operation and come in fixed or moving plate types. They are available from both manufacturers. The purpose of these sprinklers is to direct water away from the wheels to keep the wheel track dry. These emitters are normally attached to the span by either boom backs, rigid droppers, or a stabilising bar between two part circles which create a more rigid structure. If using two water sources, for example from a bore and a storage, then the dual nozzle clip permits the grower to adapt the system flow rate to the water source being used.
This is a dual nozzle clip that's put out by Nelson, and it's got quite a number of uses. We have it where guys are coming off storages or out of bores and got two different flow rates, or they're coming off they can come from two different supplies. And what it allows you to do is to change the flow rate that the machine will put out. Now, some growers say, oh, well, no, there's still water coming out, so I'm right. I don't need to worry about it. Well, that's very, very incorrect. You probably can't be more incorrect if you tried. The critical thing with laterals or centre pivots is you must get the uniformity of the water across the machine correctly, otherwise you throw the whole machine out, and that's part of having pressure regulators. But this is, we've got several clients who pull out of a storage and others that pull out a bore with different flow rate. To change the flow rate of the machine, it's simply a matter of changing the nozzle. And you can have a high flow rate and a low flow rate. The way to change it is basically you're unscrewing the spinner. This is your nozzle. It's got two different sizes. So to change it, you take it, you turn this around, and you simply screw it back on, so that you don't have to actually go and have them stored somewhere else. Those two nozzles are set for this particular sprinkler, and they have that across the whole machine. It's a great idea. We even have some clients who on Lateral Moves have a machine that's geared up for 8 mils a day and 12 mils a day, and they use the 8 mil a day on their winter crop or for watering up their summer crop. and then for the peak period they'll turn it around and put their higher flow on, just so they don't have to run their machine at maximum capacity, so it just lowers their running costs. Again, this is when you start to use these machines as a management tool more than just a watering system.
Pressure regulators are fitted on the droppers above the sprinklers. They are used to ensure that all sprinklers are supplied with water at the same pressure to achieve even application. Differences in individual sprinkler pressure arise from variations in elevation and frictional pressure loss along the system length. There are high and low flow regulators available. The system pressure should be 5 to 10 psi higher than that specified on the regulator for it to operate correctly. Check that regulators are the correct pressure rating for the sprinkler package. It's not unknown for a system to be designed with emitters operating at a specified pressure and to be supplied with incorrectly rated regulators. In theory, pressure regulators are unnecessary on machines irrigating flat ground. However, in recent times, it has become common practice to fit regulators to all machines to account for elevation and flow rate variations.
I think they're absolutely critical. Again, it's a way of, you know, if your bore starts to drop off or, you know, your sprinkler package starts to wear, it's just a safety thing you have to have. You know, honestly, I think you're a fool if you don't put them on. It adds to the price of the machine, but I think it just, you know, at the end of the day, it's going to save you so much in management time and not losing crop, especially on the outside and especially on pivots where, you know, the outside couple of spans are the last ones to get watered, and that's where your big acres are. Yeah, look, we tend to use 10 and 15 psi regulators, and the biggest determinant in there is probably, again, back to soil type, or back to management, and back to sort of topography to say, do we need that extra wetted area from using a 15 psi to get that extra throw, or not? There's a cost in using the 15 psi regulators. There's obviously you've got to have an extra 5 psi. So there's a cost in creating the energy to generate that pressure. But again, that's something that we weigh up. And again, you know, in some degrees, it depends on how windy it is, because obviously that will change your droplet size depending on what pressure you've got behind it. So there's numbers of layers that you've got to look at when you're making any decision with sprinklers. But one decision you should make is you should have pressure regulators. Full stop. Doesn't matter what sprinkler you're using.
The use of pressure regulators is only justified in case where you have you know, the topography issues. So where you have a big difference in elevation between one part of the system and another, which will eventually affect your application uniformity. In Nebraska, most systems don't need it because most land are flat. And in most cases, they are not really needed because most cases you use this system, they are flat land. So the designer should take that into account when designing selecting the sprinkler package, and that should take care of that. Only when you have it, extreme changes in elevation, then that you cannot take care of that in the design itself, then you might have to use a pressure regulator.